infrastructure to reach the desired state. And it will give you a very detailed list on what are the changes Terraform is planning to do based on your config and based on the current state of the infra. If we are okay with those plans, with those actions, we can go ahead and apply those. And when we apply, that will actually implement those changes in our infra. It will make all the changes that we have in our plan. And that will be basically what we will be doing every time, adding things to our code, planning, applying, and so on and so forth. Eventually, we may want to destroy the resources. And that's very useful when we are using an infrastructure that is temporary. We are testing something, we are deploying an infrastructure that is not permanent, and we need to destroy that. Terraform provides a destroy option that cleans up and removes all the resources used by Terraform, all the resources created by Terraform. So we're going to see that workflow in action in our demos in a moment. But before moving into that, we need to cover some of the building blocks of Terraform. And we will start with the provider. What is the provider? The provider is a plugin that Terraform uses for interacting with the target systems. So Terraform is agnostic. It can work with any kind of infrastructure. And with the providers, we basically give Terraform the capability to program or interact with certain systems. So we have a provider for ACI, we have a provider for MSO, we have a provider for AWS, for Azure, for whatever infrastructure you think of. And that provider is the one that implements the interface with that specific infrastructure. In Terraform, we need to declare or define which are the providers we need to use or we want to use, as well as provide some configuration which is normally based or related to how we authenticate to that particular system, right? Where can I find the providers that Terraform have? That's found in the registry. So you can go to the registry and you can find all the providers Terraform have. You see, it's quite a lot, the 20 pages of different providers. In particular, for Cisco, you see here we have a bunch of them, not only for the data center space, but also for things like SD-WAN and so on, and DNA Center. If we go to a particular provider like Cisco ACI, we will find the documentation. Here on the top right, we have the instruction of how to declare and use this provider in our config. We will see that how we use that in our code in a moment. And then in the documentation, you find more details. Normally, in all providers, this main page of the documentation explains how to build the provider config itself. So basically, in ACI, how to define the credentials, the URL, and other settings. And then we have all the different pieces of config we can use with our provider that we will cover in a minute. So you saw right now that we have in Cisco, we have different providers apart from ACI for both on cloud and on-prem. We have the multi-site orchestrator, DCNM, DNA Center, and Intersite, and some others that you saw in the registry. So now let's see how we can define our provider. We will have, first of all, one Terraform configuration block that you see here, where we will define which are the providers we need for our configuration. For this config, we are going to need only ACI provider. And here we specify which is the source, the location of the provider, and which is the version we want. The location, if we are using the Terraform registry, is going to be normally the developer name of the company / the name of the resource. You don't need to guess this information. This is basically in the use provider section we saw. So here you have the details of how to declare this. So you can just copy paste and use it. What about the version? The version can be something really specific like this one, or it can be another string that defines a constraint. Like, for example, I want a version that is greater than 0.5, or I want a version that is included in the major 0.7. So, for example, 0.71 will be also okay. And you can define this in different ways. When you do the initialization, the init, then Terraform will find the most appropriate provider for you, download it, and install it automatically. Then we need the provider block, provider ACI in this case, where we define our credentials. And exactly the same as in Ansible. We can choose to use username and password for authentication, or even better, we can use private keys and certificates, which is recommended. Then we define our URL for accessing our epic, and we define if we want to verify the SSL certificates or not with this insecure flag. Well, we have our basic skeleton of our config, which is defining the provider. If at that moment we do an init, as I mentioned, Terraform will find providers matching your required providers configuration, download them from the registry, install them, and you are ready to go. You have your workspace initialized. The question is, what if I want to upgrade my provider? So now I'm using 0.6, and I want to move to 0.7. Well, if I go and change that in my config and do a Terraform init again, that will fail. Because one of the things Terraform in the new versions have is that it's have a memory, or it's keeping track of the version of the providers you were using. And it will try to use the same version that you were using before, just to avoid any problem when you upgrade providers and you can break anything, right? If you change your version and Terraform is not able to, or the version you have been using before is not matching when you have in your restriction here, in your version string, then Terraform will complain, will tell you, okay, this is not matching, I have 0.6, and that doesn't match your version. If you want to upgrade your provider, you need to tell me explicitly. And then we need to use this upgrade flag. So we can go ahead and do -upgrade. And then, yes, then in that case, Terraform will download the new provider again and install it and start keeping track of this version instead of the other. Before going to the demo, let's move on a little bit more with other building blocks we need. Because so far we have defined that we want to use ACI as a provider, but we haven't configured anything. Configure something in Terraform means declaring resources. So a resource in Terraform is an infrastructure object. And if we think specifically about ACI, a resource is an ACI object. It can be a tenant, it can be a bridge domain, an EPG, whatever object you can think on in ACI. When we add this resource in our config, that is telling Terraform that we are expecting to have that in our infrastructure. And from that moment, Terraform will do whatever is needed to get that resource configured. It will configure it from the beginning. It will modify it if it's needed, or it will delete it if you remove it from your config later. Okay. Where you can find the resources we have available, which essentially means which are the objects that you can configure with Terraform. It's in the documentation. So we saw before, and let me jump into the config again, the documentation again. And you see here on the right, on the left, that we have resources, which is a very long list of things you can configure with Terraform. We see here some familiar things like bridge domains, CDP interface policies. We see some things for Cloud ACI as well, and so on and so forth. So you see it's quite a long list of things you can configure with Terraform. If a resource is not there, and it means that you cannot configure that object with Terraform, we also have the ACI REST option, which should be something somewhere around here in the bottom, ACI REST, that allows you to make a REST API call to the ACI fabric and basically configure whatever you don't find here. But we will cover that at the end. It's not the best option to use ACI REST if you have a specific resource for that object. And we will cover that later. So basically, we will take the objects we need, for example, ACI tenant. Let's find it here. And in the documentation, we have all the information to configure that particular object. We have an example that you can copy paste, and we have a reference of the attributes we can define. Some of them as you see, are relationships, are connections to other objects that you have in your infra. And that is something that Terraform allows us to do. So if we go back to our slides, we see here we are creating a tenant, bridge domain, and a VRF. And we see that VRF is linking to the tenant distinguished name. Let's take a look at how this language, how this block that we are defining works. So we have the resource block that you see that have a resource type between quotes that defines which is the object we want to create. All of them, as you see, start with ACI underscores. That is telling Terraform that it needs to use the ACI provider for this object. So ACI tenant is the type of the object we want to create. And then we have a name. This name, this resource name, it's locally significant for Terraform. It's not pushed anywhere in your fabric. It's not visible there. It's just a name for referencing this object in your Terraform configuration and your Terraform state. So you can put whatever name it makes sense for you. And then whatever is inside this resource, those are the parameters we will be configuring for that object. So you see the tenant name, STEMOTN in this case, and the description. Same for the VRF. Our object is ACI VRF, our resource type. The name is main, and this is the configuration for the VRF. And you see we have a relationship to our previous object, to the tenant. How do we do these connections? You see that we use resource type dot resource name, this demo in this case, dot the attribute we want to use. And in ACI, the ID attribute is always returning the distinguished name of the object. So in this case that we need to make a reference to the tenant distinguished name, this is the way to do it. And this is really important because so we can basically write it manually, the distinguished name if we want to between quotes. But that will break certain things that Terraform allows us to do. One of them is calculating the dependencies of the objects. Using this approach, the referencing objects between each other when it's needed, it will allow Terraform to calculate in which order it needs to configure the things, and it will allow Terraform to know which objects needs to be modified if I change my tenant, for example. It will find all the dependencies and will rebuild or modify all these objects as it's needed, okay? And that is what basically is the powerful of Terraform, is what makes Terraform so smart and so powerful. And if you don't follow these kind of things, that will basically break that behavior of Terraform. Once we have our basic config ready, we need to run our plan and our apply. If you remember the workflow, we write our code, but then we need to initialize the environment, do the plan, and do the apply. Let's see what is the plan. So when we run the plan, Terraform goes to the infrastructure, query the states, and verify what is the delta between what you want to configure, what is configured already, and what is the configuration file telling. And based on that, it will tell you which are the changes that needs to be done. So for example, if we run our example, we'll do that in a moment, you will see that Terraform needs to add or create 3 new objects. And it's going to tell you which are the parameters for that object. Some of them will be known after apply, which means that it's not defined in your config, and it will use the default value, which will be provided by the epic after configuring the object, okay? Then we do the apply. And the apply will effectively push the configuration to the fabric. When we do the plan, we can optionally save the plan into a file. And that will allow us to provide this file to the apply phase, and the apply phase will apply exactly what is contained in that file, no matter if the infrastructure changes. So imagine you do the plan today, and you run this configuration, you run the apply tonight because you have the maintenance window, right? During during all the day, someone can make a change in the infrastructure, and then your plan can change. But your plan is already approved, so you already verified what are the changes to be done. If you want to make sure that those are the changes that are done and nothing else, you can use this particular file, no, and save the plan in the file, and then use it. If you don't, the apply will create a new plan on the fly at that moment, and then you need to approve it in this particular moment. So we'll see both things now. Actually, let's move on to the demo and let's run it. One comment I wanted to mention: all these demos that I'm running today, they are in my GitHub repo, and they are available for you, so you can download them, you can play with them in your lab, test it, do whatever you want. So we're going to post the link to the GitHub repo in the chat, so you can access these examples, and also it's in the reference in the slides, so you also have the link there. Let's see our first example. This is a very simple one. We are creating our tenant, VRF, and bridge domain. First of all, we need to start with our provider configuration. So we define which is the provider we want. In my case, I'm also defining the Terraform version I want, which has to be higher than 0.13. And then my provider configuration. In my case, I'm using certificates and not passwords. Then we define the resources we want to create. So I want to create a tenant called demo_tn, and then a VRF inside that particular tenant and a bridge domain. Now this is in the order where you normally do the config in ACI. No? First the tenant, then the VRF, and then the bridge domain. But let me show you that I can basically change this order. I can put the bridge domain first, and then the demo, and then the VRF. If we can try to do something like that in other tools like Ansible, this will break because the tenant cannot be created before the BD cannot be created before the tenant. But Terraform will solve this for us. No, thanks to the relationships, Terraform will know in which order we need to do the changes. Let's start by doing an init. Oops, let's change to the folder we are, and then let's run Terraform init. And as we mentioned, now Terraform is checking which is the provider I'm using, is downloading that from the registry and installing that. And when we do that, we see we get two files in my directory. One of them is the log file, which is the one that takes care of controlling which provider I'm using at this moment. So 0.7.0 is the one I'm using. And then I get another folder, .terraform, where my provider is installed. It's another binary that we downloaded from the registry and put it here. So this is what we get when we initialize our environment. Now let's do a Terraform plan. I didn't specify any file, so this plan is not safe anywhere. Let's take a look at the plan. So Terraform is telling us, okay, this is what you need to change. We need to create the bridge domain with these parameters. We need to create the tenant, and we need to create the VRF. At this point, nothing is happening. I'm not creating anything in the epic. So if we go to the epic now, you see that nothing is created. It's just a calculation of what should be created for reaching our desired state. Based on this, I can decide if I'm happy to go forward or not, or if I need to make any change to my config. If I'm good to go, I will go ahead and do an apply. As we mentioned, as I'm not providing any file, the apply is calculating again the changes, and it's showing me another plan. And this will be the final plan. This is the one that actually matters. Whatever is here is what Terraform is going to execute. So if I'm happy with this, I can say yes, and then Terraform will create all the objects. And you see that now Terraform is creating the objects in the correct order. So first is creating the tenant, then the VRF, and then the bridge domain. And now everything is created that I have my tenant here with my VRF and my bridge domain. Bridge domain should be appearing now. Okay. Perfect. What is happening when we run our first apply and we start basically creating objects with Terraform? Well, immediately Terraform starts keeping track of these objects. It creates a state file that we have here, in which is keeping basically track of all these objects and the state of these objects in your infrastructure. So this file is supposed to be a representation of what you have running in your real fabric. This is what will provide us all the capabilities that Terraform have now about detecting config drifts, being able to delete objects, and so on. And this is what we are going to see in the next section. We're going to see how ACI, how Terraform behaves when we start creating things manually in the Epic, when we want to delete objects, and how to do it in a safe way, and how the state basically works. So let's move on. I'm not going to use the slides for this section. First of all, we have here our state file. This state file is in JSON. We are not supposed to touch this file. So this file is internally to Terraform. And if we want to modify or manipulate this file, we have to do it through a set of commands that Terraform provides. For example, let's imagine I want to list all the resources I have created by Terraform. I can do a Terraform state list, and that will give me a list of resources I have created. Is this all the objects I have in my fabric? No, these are the objects that I have managed from Terraform, only these three. If I want to see one specific object, I can do Terraform state show, and then put the address of the resource in particular, for example, the bridge domain. And then I will get the state of that particular bridge domain with all the attributes that Terraform has read from the infrastructure.
Alejandro, if I could ask a quick question, because it got me thinking. So in the Q&A, Hitesh asked a question about when you apply a Terraform plan and something fails. So I was thinking, what if you had a provider, and it was like beta version, and the developer maybe made a mistake in the provider. And when you do your Terraform init and your Terraform plan, right, everything kind of checks out. But before you actually send it, right, and commit it, let's say it goes through the steps, and when it hits that bug in the provider, something in the plan doesn't work, it fails. What happens? Is the plan sort of an all or nothing, which is what Hitesh was asking, or does it try to configure everything and then sort of throw an error if there was some object that something went wrong with? Do you know?
Good question. It depends on the error in the provider. If the problem is triggered also in the plan, then your plan will fail and nothing will happen. Nothing will be configured. Nothing will happen. If the problem happens during the apply phase, and it can be a problem in the provider or it can be a problem in the target system or whatever, no? But if something fails in the config, Terraform will not revert what it has done. So basically the config will remain in an intermediate state. The moment it fails, it will stop by default, and what is configured is configured. It will not touch it or read or undo the changes. If you want to undo the changes, you have to do it manually. Manually with Terraform, but you have to do it explicitly. Okay.
Right. Okay. Thank you. But given this is an immutable architecture kind of approach, I can sort of see that being a very rare corner case that you would then quickly move to fix, and that becomes the current working state of your fabric. So, okay.
Yeah, and that's why we have or Terraform have this control of the versions of the provider. And that's specifically why this is there, no? Because in Terraform we don't want to upgrade to a new provider by mistake, okay, or without in a non-controlled manner. Start using a provider that is new and that maybe can break or cannot work fine in our infrastructure. So Terraform will continue using the provider we know it's working because we have tested it. And if we want to upgrade the provider and use a new one, the correct process in production will be to test it first in a development environment, see that the provider works as expected, and then modify our configuration file with the new version we want. No? So for example, I will put here 0.7.1, and then that will be effectively upgrading the provider. And that way, I'm sure that the provider I'm using is working as I expect. Okay.
Thank you. Another quick one. I think I know the answer, but since I've got your attention, this is the question from Nix. Is the annotation setting, is that a mandatory field, or can you opt not to show annotations when you push something to ACI with Terraform?
No, that's embedded. It's embedded in the provider, so the provider will do it for you, and you cannot control that.
You cannot remove it, so it will always show up as a sort of a failsafe to let somebody else who might be manually configuring APIC that, hey, don't touch this object because we pushed it through Terraform.
Exactly. Yeah.
Okay.
Exactly. It's something that happens out of the box with the provider.
Okay.
If you see, we didn't specify that in our config, so
right.
it's something that
right. Okay.
we didn't. It's something that the provider is adding when it's pushing the config to ACI.
Now, just for nerds like Nix and I sake, sorry, Nix, I don't think you're a nerd, but I am. Is we could use an API call to APIC and actually remove the annotation, but then again, we would then drift from the state that's here, right? Like, if it's just like the little icon annoys us and we just don't want to see it. You know? Okay. But that wouldn't be a good idea because we would be drifting from state, and then the next time we applied, it would show back up. So what's the point, right? That's the right answer.
Yeah.
Right. Okay.
Yeah,
All right.
exactly,
Cool. Thanks.
exactly.
Thanks for entertaining our crazy questions, Nix. I hope that was useful for you as well.
No problem. No problem. So, so we are managing our state. We can show the state of a particular object, and now connecting to what Joe was mentioning. What if we change something manually in ACI? So one of the powerful things about keeping track of the state is that we can detect config drift. So let's go to our tenant and let's make a manual change. Let's imagine someone goes to our tenant. That person that didn't care about the annotation that we were mentioning, right? That it tells you this has been created for an orchestrator. Please don't touch it manually. Well, I don't care. And I will go ahead and change this to flooding. From hardware proxy, which is what I configured, I will change it to flooding. And I will go ahead and submit my changes. Okay, now my bridge domain is in flooding. And this is not what I had in my Terraform configuration. What's going to happen now? Well, if I do a Terraform plan, Terraform is going to refresh the state from my infra, and it's going to compare that to my configuration file. And voila, it's going to tell me let's take a look here. Well, someone changed your bridge domain from proxy to flooding. And that's there was a change that was made manually outside of Terraform since the last time you applied your config. What I need to do to basically fix this drift is to go from flooding to proxy again. So if I do a Terraform apply, that will be actually the configuration I will apply. Okay? It's going to tell me you need to change from flooding to proxy. I'm okay with that. Let's go ahead. And now you see that the configuration has been reverted. Now let's do another test. What if I change something that I didn't specify in my config? Let's imagine I write a description, and the description in the bridge domain is something I didn't specify in my config. So if we go back to our configuration, you see in the bridge domain that we don't have any description. Let me remove that. That was broken. Okay. It's something that I didn't specify in my config. What's going to happen then? Well, how Terraform behaves in these situations, it really depends on how the provider is implemented. In ACI case, and in all the data center networking providers, the way it works is that if you don't specify something in your config, Terraform will inform you that there has been a change, but it will not revert the change. So let's see how that. We get here a warning telling Terraform detected some changes done manually outside of Terraform. This is the change. Someone added a description. But if we scroll down, we see no changes to be done. Your infrastructure matches your config. So that's the way our providers work. If there is a change done manually in a attribute that we didn't set in our config, it will let us know that it has been changed, but it will not revert that config automatically. If we want to revert that, we have to add the description to the parameter and put it with the value we really want to have, like blank, for example. No? That is good because it allows us to, it will be more permissive to the changes we can do manually in the fabric. while at the same time it's informing us if someone make a change manually. Let's imagine I want to bring this change to Terraform. I'm okay with the manual change and I want to bring it to the state. If I do a Terraform refresh, which is an alias for another command, but we can use it as well. Now, that description is part of our state, and Terraform will no longer say that there is a manual change outside of Terraform. Okay. Perfect. Let's see another thing. What if we want to rename an object? Let's imagine I want to rename my VRF. And here's where we are going to see the mutable part of Terraform. Instead of calling it main VRF, I want to call it demo VRF. So if we think about what's happening in ACI when we rename an object, the process is, we cannot rename an object. We need to delete it and create it again. And then all the references to this object needs to be redone. For example, the bridge domain that is pointing to our VRF, it needs to be modified. So let's see what Terraform does in this case. If we do a plan, Terraform is going to do exactly what we are mentioning. It's going to tell us, listen, the VRF, you are asking us to change the name, but changing the name is a change that forces replacement. I cannot do it inline. I have to remove your object and create a new one. And as I'm creating a new one, your reference in the bridge domain will change. So I need to go back and change that reference. And here you see why it's important that we keep these references between objects, because otherwise Terraform will not do this change automatically, will not detect these dependencies. So now that I did this, I can do an apply, and Terraform will actually make these changes. Okay, we'll basically rebuild the VRF and modify the bridge domain to bring our desired state in the infrastructure. No?
Alejandro, quick question. Just sort of following on another question from Hitesh. Is there a log of all of the Terraform plan and applies that happens? Like if I wanted to go back and look at maybe the state from 4 versions ago, or maybe detect an error or a mismatch, is there a way for me to automatically log my state somewhere?
Not if you are using Terraform CLI. So let's break that question down into different pieces. The state, if you see, automatically Terraform is doing backups every time we change the state. So it's keeping a number of backups of the previous states just for your reference, or in case you need to do some operations with that. No? If you want to keep a track of what Terraform has been doing, like the changes and so on, that's something that with the CLI tool, the free tool, is not keeping track of. However, if we move to Terraform Cloud, then you keep track of all the runs that we are doing. So I think I have it open. No, I don't have. But I will show you later at the end. So hold the question, okay? And at the end, I will.
Fair enough.
I will show Terraform Cloud.
Thank you.
But in Terraform Cloud, we keep the track of all the runs. If they fail, if they succeeded, what was the changes and everything, and we keep a list of all that. Okay.
Perfect.
Not with Terraform CLI.
I think that's enough to answer the question. Thank you.
No problem. Let's move on with let's play a little bit more with the state. Let's imagine I create an object manually in ACI. For example, a new bridge domain. Now the question is, will Terraform revert this change? Will basically delete the bridge domain because it's not in my config? Let's see. Let me select the VRF. Okay. Now let's do a Terraform plan. You can forget about this. It's a cosmetic thing that we are fixing in the coming releases. But you see that the bridge domain is not detected by Terraform. But that's a very important thing. Whatever object that is not in our state is obviously, if we delete the tenant, as the bridge domain is inside, the bridge domain will go away. but it will not manage or modify that bridge domain.
Alejandro, we lost audio for a second. Did you switch over to something, or did something happen?
Can you hear me now?
Yeah, we can hear you now. Just the quality of the audio changed a little bit more echoey. I was just wondering if you were aware or not, just in case.
Now it's okay, right? Can you hear me now?
Yes, yeah, sounds good. Sounds good. Sorry.
Okay, yeah. Okay. The headset flip, the Bluetooth dropped for some seconds.
Okay. Okay. Good. Okay, you're good now.
Perfect. So coming back a little bit, we created the bridge domain manually. It's not managed by Terraform. Terraform will not do anything with that object. But what if we want to bring that object into Terraform management? That is an operation that is called an import. And we can take an object that is fixed already and bring it to our state. For that, we have to use the Terraform import command. And the format of that command depends on the resource. So we can go to, for example, the bridge domain in our documentation. And we can go down here and see what is the import command. I'm not going to do it because of time, but with that command, you will bring the bridge domain into your state. If you do that without doing anything else, Terraform will complain because that object is not in your config. So you need to add the skeleton of the object first and then do the import in order for it to work. But just to tell you, you can import things that exist already into Terraform and start managing them from Terraform. And to finish with this state part, what if I want to delete an object, or let's say stop managing an object from Terraform without deleting it from the infrastructure? Let's imagine I want to stop managing my bridge domain. For that, if we just if we remove it from the config, let's do it. Okay, let's see. If we remove it from the config, what will Terraform do? Terraform will tell me that I have to remove it, and will try to basically delete the object. But as I told you, I want to keep it. I don't want to delete this object. I want to keep it, but not managed by Terraform. So to do that, we need to remove this object from the state. And this is something that, again, you shouldn't be doing in the state file directly, but using the command. So it is a Terraform state rm for remove, and then we specify the address of the object. The address is always the resource type followed by the resource name we are using. So we'll copy that, paste it, and that bridge domain is no longer in the state. If we see what we are managing from Terraform, it's only the tenant and the VRF. And now if I do a Terraform plan, Terraform will not tell me anything about the bridge domain. Let me remove that thing. Okay. It's telling me that my infrastructure matches correctly the config. So now basically I stopped managing my bridge domain. The bridge domain is still there. No one deleted that, but it's no longer under the control of Terraform. Okay, so this is the correct way of stop using an object in Terraform without deleting it from your infra. So most of the things I explain now are in the slides in the infrastructure state part. So if you want to review the slides after we publish the PDF, you can take a look at that. Regarding the logging that someone was asking, if we want to see the logs of what is happening under the hood because there is a problem or whatever, we can enable the debugging in Terraform. And this is the way to do it. It's exporting a specific environment variable with the level of debugging that you want to enable. And you have multiple options. If you go to documentation of Terraform, you find how to send the logs to a file, how to log only specific parts, and so on. So there is an option. Let's skip this part. And let's move on a little bit. Now we did our basic config, but this config is everything is hard-coded in my file. So if I want to modify the tenant name, I have to go to my code and do it. It's better if we use variables. So that way we can define our values in a separate file and keep our code reusable and clean of variables, of hard-coded values. So in Terraform, the variables have a type. So we have to define if this is a Boolean, it's a string, it's a list, it's a map, there is a different types of objects, and you can also add a description. You can add default values. You can add even validation rules and so on, or hide the values if you flag them as sensitive. They will be hidden in the outputs of the logins and these kind of things. And here is an important concept of Terraform. In Terraform, we need to define in advance what are the variables that we are expecting in our code. So this is done this can be done in a separated file or the same. Normally, we use a separated file for this, and we define that with a variable block, where we put the variable name, and inside we put all the configuration of the variable, the type, the description, the default value, and so on and so forth. Then we need to use the variables. And for using the variables, we can go to our code and use the var dot syntax. Var dot and then the name of our variable we want to use. You see here two different syntax. This is the new one. This is the previous one. And I'm adding the previous one because if you want to do things like this, like including your variable inside a longer string, then you need to still use the old one. Okay, with the new one, it's not working. So both are still applicable. And most of the examples you will find out there are using still the old one, but you can use the new one if you want. So we defined our variables, we use them in our code. Now the question is how we set the values of these variables. And for that, we have multiple options. You see here a list of options we have. We can provide them in line. We can provide it as environmental variables. We can provide it in a file. And depending on where you provide them, there is also a precedence, an order, or about when this, how this variable will be read and which one will be applicable if you define it in multiple places. This is here in the Terraform documentation. In the example we are going to see, I'm going to use a variable file that I'm going to call in my apply command. So let's see the demo. This is demo 02. It's a different folder, so it means I need to initialize the environment again. In Terraform, every folder is a different environment. So let's move to the new folder. Let's do a Terraform init. And the same is going to happen as before. And in the meantime, let's take a look at our files. So this is my Terraform code. In this case, you see I'm using variables for pretty much everything. So almost nothing is hard-coded in my config. My variables files are here, defining which are the variables I'm expecting. So tenant name, BRF name, and so on. And my variable values are set in a separated file, which I only say variable name equals value for that variable.
Alejandro, if I may.
Yeah.
The question around the importing the brownfield environment into the Terraform. So let's assume that we have the infrastructure already built. So in order to import these objects into the Terraform, should I, build the skeleton of all the objects that I already have implemented?
Unfortunately, yes. And this is not something depending on the provider. It's something related to how Terraform works. So if you want to import 20 objects, you need to create those 20 objects in your config and then import the state. So as of today, Terraform, when you do the import, it doesn't create the config for you. Just import the state. Okay.
Right. Thank you.
When you import the object, so you just put the skeleton and you import the object, in the state you get the configuration of the object, and you can use that to build your config matching what you have. So you have this kind of help, but you need to write the config yourself at the end.
Yeah, sure. Okay. Thanks.
No problem. So now we have our plan with the external variable file, and you see that when you need to add the variable file here, if we omit this, instead of using the variable, which is production BRF, for example, for the BRF name, we will be using the default value. So this is the way of reusing code. You can reuse this code for or send this code to someone, and that person only needs to set the variables to their values, to the values they want, and reuse this piece of code. With the same logic, we can create later modules. So we will explain a little bit later at the end of the session. to basically build like functions that you can reuse in your code over and over and over, which has some variables input, like this one that you see here, and some outputs as well. So it's just like a function, and you can reuse that block of config in your configuration files. Perfect. What if I want to create 20 bridge domains? Do I have to build basically my config with 20 resource block for this? Well, fortunately, no, because we have loops in Terraform. So let's move on. And we have two options for doing loops in Terraform. One is specifying how many objects I want with the count expression inside my resource, and that will create basically 10 bridge domains. But the problem with this is that the only thing I can change between different resources is I have the index of the count, and I can play with that, but I cannot set the values of my variables differently for every object, at least not with the code you see here. There is a better option then, which is using the for each loop. The for each loop will take a variable, which is a map of objects. We'll see now how a map is built. So we take the map and we create one object for each element that we have in that map. Let me show you how the variable first is built, the bridge domains variable. So this is a map. A map is similar to a dictionary in Python. It has a key and it has a value. The key is always a string. And if you see here my variables, BD01 and BD02 are the keys of my map. The value is this list of things. So this is an object where I specify different fields inside it. So those are the fields I am expecting per each bridge domain. And now I can create multiple of them. I could add to this bridge domain list another object, BD03, with another parameters, and that will be my list of bridge domains. My for each loop is going to take every of these elements and define a new resource per element. How can I refer to those variables inside my code? Well, first of all, we have the each keyword that is representing the current object in the loop. So every time we do a new iteration, that each will take the value of the bridge domain we are creating. And then we can access either the key or the value of that object. The key will be BD01, as we saw, and the value will be that complex structure. So we can add another dot and then follow by the attribute we want, the name, the flooding, whatever attribute we have. That's much powerful because we can, with a single resource, we can create as many bridge domains as we want. And we just define in the variable a list of bridge domains we want in a very easy way. Let's run this 1 second. I'll list the plan so you see what's going to create. So let's go to the demo 03, let's do an init, and now let's do a plan. And pay attention that now in the plan, I'm not going to provide the variables file. Why is that? It's because I'm using a file called auto.tfvars. All the files called auto.tfvars are automatically imported when you run when you execute your plan or your apply. They are automatically taken, and the variables are automatically read from there. So if we see here, we are creating 2 bridge domains, and you see how the bridge domains are called now, which is the address of the Terraform element. It's using the resource type followed by the resource name, and then between square brackets, we have our key of the object. And this is the reason why we need objects with the key. It has to be a map. It cannot be just a list of objects, because a list doesn't have a key that we can use in Terraform. So remember, the key you use in your map is going to be what references the object in Terraform. Perfect. I'm not going to execute this because it's the same as previous examples. But if you want to run those things in your environments, in your labs, and play with that, remember you have the code available for testing all those. Next thing we can do with Terraform is conditionals. And again, we have 2 different types of conditionals. We have inline conditionals, where we define an expression, then a question mark, and then the value if the expression is true, colon, the value if the expression is false. And we can combine this with things like count. So if this condition is true, count will be 1, meaning that we will create 1 object of this type. If the condition is false, we will create 0 object. So basically, we will skip this resource. It will not be created. Here you see another example of the inline conditions, where we are evaluating one variable, and based on that, we are setting a different value in the string. In this case, if the bridge domain is layer 3, we set proxy. If not, we set flat. What if we want to use conditionals together with for each loops? Then the syntax becomes a little bit more complex. For those of you that has been programming sometimes, even basic things, this syntax will not be very complicated. But basically, what we are doing here, we are taking our list of bridge domains, and we are basically filtering that list of bridge domains. We are evaluating all of them. If the type is layer 3, we return that object. But if the type is not layer 3, we filter that out. So with that expression that you see in the screen, you will get a list of bridge domains filtered by a specific condition. And then that resulting list will be the one you will use for the loop. So if you want to see how this works with more detail, you can go to the demo number 4 and basically test it out in your environment. So here you have the demo with that particular code. That's basically the way conditionals work in Terraform. And with that, you can basically add some logic to your code to basically get a little bit more power. Let's change topic a little bit. So far we have been creating things in Terraform. But what happens if we have something already in our infra and we just want to use it? We don't want to manage that from Terraform, but we need to use it in part of our code. One example could be a physical domain that we already created a long time ago, or a VMN domain, and we want to use it when we deploy an EPG. How can we do that? For that, we use data sources. It was the last piece we weren't mentioning yet about Terraform. What is the data source? Data source is a read-only element in Terraform. So we are, instead of configuring something in your infra, we are just reading for your infrastructure and getting all the information about that particular object. If we go to the documentation, we can see the list of data sources we have, which basically is a one-to-one mapping to resources. Everything you can create, you can also read it. For example, bridge domain. And to read it in ACI is as simple as putting the name of the object you want to find. In some cases like this, as the bridge domain is inside a tenant, you need to put also the tenant distinguished name before. This data source will read that particular bridge domain and will return all the attributes of the bridge domain that you can use later in your code. So basically, you are reading data from something that already exists without managing that in Terraform. So that's very, very useful. What if the object doesn't exist in your infra? Then you will get an error when you try to execute this or do a plan. It will tell you that the object doesn't exist, and we will stop. No? Even during the plan, so no need to apply this to get the error. And you see here an example of code where we are using a VMM domain in particular. Last part that we are going to cover today about Terraform. What if the module doesn't exist? This resource doesn't exist. We want to create something that is not supported at this moment by our ACI provider. Well, in that case, you can use the ACI REST resource. That is basically allowing you to make an API call to the fabric. Here you see an example. Oops, sorry. Here you see an example with a pre-login banner. This is something that we don't have in our provider at this point. And with that, you can configure that with an API call. But you need to be careful with this, because all the things I've been showing you about tracking the configuration drift and all that things, they are not working with ACI REST. ACI REST is not capable of detecting configuration drifts. So when you are using this, you are missing some of the value of Terraform in terms of tracking the state of the objects, tracking the configuration drifts, and so on. So what is the guideline here then? It's use ACI REST if there is no object and you have to create that object. But if there is a specific resource, use that instead. And now the challenge could be, what if I don't find the resource I need? So one of the problems I find when I'm using the provider for ACI is that sometimes the name that we use here doesn't match what you see in the GUI, or doesn't match what the name of the class in the code in the API. And finding the resource could be sometimes a little bit tricky for some specific objects. What if I want to find that? Well, let me show you one trick for this. First of all, you click reporting an issue, you can go to our GitHub repo, which is totally open, and you can see the code that we are implementing. Recommendation number one, if you are using ACI REST because the resource doesn't exist, one thing you can do is open a new issue in our GitHub, requesting that particular object. That way, our team that is creating this will track that requirement and will put it in the roadmap to create that particular resource. The second thing is how to find a specific resource. If we go to the code ACI folder, we see here all the resource and data sources that we have. So here, if you see the name, is actually the class name of ACI. So if you know how to create that thing with the API, but you don't find the resource in Terraform, you can find here by the class name. So for example, FBVD, you see here the data source and also the resource. So now you see this is the resource that creates a bridge domain. And if we get into it, you see here the name of the resource. It's not containing the underscores, but the name is this one, ACI bridge domain. So with that, you can get a hint and go and find that in the documentation. Even more, there is an object here. Sometimes I don't remember the name by heart, but let's find it. There is a piece of config here, provider.go, I think, that contains the mapping, between the resource configuration that I just showed you and the name of the resource in the provider. So you can also find it here if you need. Perfect. So that's everything about that I wanted to explain today about Terraform. So with this, you should be able now to go and start creating your configurations, similar to the examples we created, obviously including much more objects. No, so the logic is the same. The only thing is that you need to add more and more resources to build a bigger configuration, right? There is another demo we didn't cover because of the time that includes a module. And the module is this function that I explained you that you can use in your code. So if I showed you this quickly, you see that we are using a module which creates a layer 3 out. The module is in a different folder that is where we define our code for the module, our input variables, and our output variables. And then we just use the module. And the module has a set of attributes that we can set in the module. And then the module will basically perform a function. That function could be create a layer 3 out, could be create a VMM domain, or could be create an application that you are creating often in your infra. Okay. Those modules, you can be creating them and sharing them in different ways, so the people in your organization can use them. And that's something that it's very interesting when you start becoming more skilled with Terraform and you start thinking about using this in production. And that's exactly what we are going to discuss now. What's next? What if I'm already using Terraform? I am familiar with whatever you explained today, Alejandro, and I want to move forward. I want to start using this in my production data center to basically manage my real infrastructure. What kind of things should I look for? Should I look into before that? There is a very important thing that we didn't get the question, I think, Joe. maybe we got the question and you answered that, no? But what about the state file? So far, I am showing you that the state file is sitting in my computer. What if Joe or Jacob, they want to manage the same APIC from their computer? What's going to happen? Well, let's actually check it out. No? Let's imagine they go to their computer, they have the same code, but they don't have my state file because it's sitting in my computer. Let's remove this. Okay. If I go now to my folder, this will be basically what they will have in their computer. They will have the code, but not the state. If they run a Terraform plan, Terraform will tell them that they need to create the objects again, but the objects already exist. So the problem is that if the objects are not in the state file, or you don't have a state file, Terraform will recreate everything according to your config. So what does it mean? It means that for working as a team, for working many people deploying the same infrastructure, which is something you do in a real environment, keeping the state locally is something that is not okay. You need to look into using remote backends. Remote backends is something Terraform provides to keep your state in a remote location. That remote location can be things like an S3 bucket, or can be, there are different remote backends. The one I really recommend will be the Terraform Cloud. There is a free tier of Terraform Cloud that you can use for using just as a remote backend. So you don't need to, it has no cost, or it didn't have cost last time I checked. And you can basically store your state in there. This is the case, for example, if we check this one. No? This one is a free tier workspace, and I have here my state stored with the different versions. So this is answering the question we got before, and it's also keeping track of my runs. Not in this case, okay. Not in this case, because this is the free tier and doesn't keep track of the runs, but it's keeping track of my state. So if someone else is going there and is using the same backend, they will be using the same state as I have, so we will not be recreating the object. We can work as a team thanks to this. That's the first thing you need to look into. The second thing is modules. That, as I mentioned, is a way to take your code, make it reusable, make it simpler to understand because you are hiding some of the details, and also make your code hierarchical because you don't put all the code together in the same place. You break it in modules that are reusable, and then you just call those modules in your main code. A similar idea that we have with coding any language, like Python or Perl or whatever, same idea here. And that is something that is very useful when you are starting to manage a large infrastructure. Last but not least, you can think of moving to Terraform Cloud for Business, which is the paid tier of Terraform, which is a SaaS product. It's basically allowing you to manage all this workflow of Terraform from the cloud. And it provides a lot of added value to the workflow. Things like, for example, run these applies and plans and everything from the cloud. Run them automatically when you do a new commit or push new code to your GitHub repository that you're using. You have some tools for collaborating as a team, adding comments, approvals, different things that you can get thanks to using the Terraform Cloud. The question you may get is, well, if Terraform Cloud is in the cloud and my ACI fabric is on-prem and my APIC obviously is not exposed to the internet, how can Terraform Cloud manage my on-prem infra? And for that, Terraform Cloud provides agents that are sitting in your data center, that are connecting in a secure way outbound to the cloud and checking if there are some jobs to be done. When there are some jobs, they take the job, they do it locally in your data center and report the result back to the cloud. That's the way you can manage on-prem data center from the Terraform Cloud. You can go a little bit further and use Intersite service for Terraform. This is a product part of Cisco Intersite that provides not only this agent capability in an easier way, but also provides things like a single sign-on and some other capabilities that added some value. Last but not least, when you have Terraform Cloud, one of the things you can do is concatenate different workspaces. Let me explain this. Let's imagine you are the team handling the networking part, the networking infrastructure, and you need to deploy some infrastructure both in the ACI on-prem and in the cloud ACI. So you can prepare your code in your workspace for configuring the APIC and the MSO and everything. But once that part is ready, there is another team that is taking care of the virtualized environment. So VMs, cloud instances, and everything. Those need to do their job when your job is done, because the infrastructure comes first. So what you can do with Terraform Cloud is to connect those workspaces together. Once you push your new code to your networking repository, that will be automatically plan and apply from Terraform Cloud. And then when this is ready, it will trigger a new plan and apply in the other workspace, in the workspace managed by your colleagues running virtualization. And that workspace will verify again if something needs to be done, what needs to be applied, something needs to be modified, and so on. And the same idea, you can extend this as how many workspaces you want. You can have a workspace for your shared infrastructure, another workspace for your production tenant, another workspace for a particular application, and all of them can be connected together. So if you make a change in the basic ACI config, you will check all the other workspaces to see if they are impacted by your change and if something needs to be modified. So that becomes very powerful when we are starting with managing a large infrastructure. You can even include notifications in this workflow. So we can get WebEx messages every time we make a change or make an apply or whatever. If you want to see all this that I'm explaining, we will have, in the coming months, we will have another webinar of this series, of this programmability series, that will cover specifically all these things. We will show you more advanced things about Terraform. We will show you Terraform Cloud for business working with ACI, with all these agents and these connecting workspaces together, and so on. So you can get a better idea of how Terraform may work when you're using that for a production environment. And with that, let me close here and let me basically remind which are the key points that we covered today. First of all, about Terraform. Terraform is the tool that is, I would say, the de facto tool when it comes to automate your infrastructure as code. It's the tool that most of the people use. It's very popular, especially when we talk about hybrid cloud environments. When using Terraform, you write the desired state for your infra, and Terraform takes care of the rest. And we have seen how Terraform is capable of detecting drifts, deciding if something needs to be deleted and recreated, and every action will be taken care of to reach the final state that you have in your files. When it comes to ACI, you have seen that there is an extensive list of resources you can use. So pretty much every object that you normally need in an ACI fabric, it's already supported by our provider. And if in the case that something is missing, you always have the ACI REST to fill the gap, and you have the option to let us know that you need another resource to be added. And we talk up today about ACI, but ACI is not the only provider we have in our data center networking portfolio. You saw that you can do the same with DCNM. You saw that you can also automate multi-site orchestrator from Terraform as well. And this is something that we will also show you in further webinars in the future, part of this series. At some point, I think it's the last one, we will show you how to automate a multi-cloud environment with on-prem and cloud and MSO next to that orchestrator to automate everything from Terraform. Here you have a set of references, a set of links to the documentation. Some of them we already saw it today during the webinar. And at the end, you have the link to the repository where you can find all the examples we were covering today. And here is the list of the coming webinars that we will have part of this programmability series. So the next one that is happening in October is about automation tools. We will talk about Git. So if you are not very familiar with Git, this is a very good opportunity to learn a little bit more. We will be covering things from Git that normally people don't use it, but you may need it if you are working with modules, in Terraform in particular, things like tags and versionings and so on. And we will cover something that I really like, which is Visual Studio. It's the tool I have been using, this one, that is very powerful and also very well known when it comes to programmability and automation. And I will make an introduction to this tool and also show different plugins that you can install to enhance how Visual Studio Code works, specifically for things like Terraform, Ansible, and so on. And then we have more things that will be coming in the coming months. Automating ACI with Ansible Tower, automating ACI with Terraform in the cloud, putting all the things that we have seen in this series together to show you how you can manage your infrastructure as code, as a whole, including all the pieces that we have been covering these days. And last but not least, how to automate a multi-cloud environment when we have multiple sites, some of them on-prem, some of them in the cloud. Here you have as well the calendar for our coming events. So today we have the automating ACI with Terraform. 16, we have another webinar about multi-site, where we will show you how to deploy the infrastructure, best practices, more about multi-site. And in October, we have Nexus dashboard, we have Cloud ACI to show you how you can leverage ACI capabilities in the cloud providers, and more about programmability and more about multi-site again. So it's a pretty busy months of September and October. So I hope you can join us for the coming webinars and you can leverage all the information we are providing here for you.
Alejandro, so
with that, yeah.
Couple of questions from the audience. So there is one question from Gustavo. Can we feed TFV vars file from the external files like XML spreadsheet or CSV files, or from the external database?
The only format that Terraform supports for TF vars, it's JSON and HCL, which is the language we have been using. So if you have another format, you need to basically transform that into a format that Terraform takes or accepts.
Right. There is another question from Hitesh. Can we have multiple variable files? So, for example, can we split one file for the bridge domains variables, one for the EPGs variables, and so on and so forth? Can we have multiple of them?
Yes, absolutely, and that's totally recommended. So if you see a bigger configuration of Terraform, that's split in multiple files, including multiple code files, configuration files, and also multiple variable files. And Terraform will put everything together for you, so you don't need to use a single file, not for the code and not for the variables. Okay.
Great, thank you.
Regarding the variable question that we got before, having the TF var files is not the only option. So there is options to define that in the Terraform cloud itself. You can define that as environmental variables. Maybe playing with these different options that Terraform provides, it can be, achieve the use case that this person was asking about importing from different data sources. So for that, I will recommend you to go to this page that we saw in the variable piece. We go back to the slide. This particular link. And here you can find all the different options for defining variables, the precedence, and also the options you have. So you can get some ideas from here. Okay. So with that, do we have any other questions, Joe, Jacob? All good?
All good, yes.
Perfect. So with that, thank you everyone for joining today's webinar. Remember that we will continue the conversation in our customer communities in the CCP that we were sharing the link, and we will post also there the PDF and the recording when we have it. So you can go there and find all this information again if you want to review that. And with that, thank you so much, everyone. Thank you so much, Jacob and Joe and Federica for being here as well. And see you next week.
Thank you.